everyone, and welcome to section 7.3 on simplifying complex rational expressions. Might get a little bit rocky here, so just kind of hold on. A complex rational expression, we've kind of talked about this before, is a rational expression in which the numerator or the denominator, or perhaps both, contain a rational expression. So something like this. And what we are going to be doing in this section is simplifying things that look like this. We already did a little bit of this when we talked about division, so it's not so surprising. Let's go ahead and hop to it and see what we can get accomplished. So what we want to do is rewrite it in terms of division, and then rewrite that in terms of multiplication. We know we're going to have to factor, so let's do that. The only thing that needs factored, though, is the denominator of the first fraction. And this x minus 4 divides out, so we're left with 1 over 3 times x minus 3. That wasn't so bad. Let's have a gander at this creature here. Again, we want to rewrite in terms of multiplication. So since I'm dividing by 2x squared minus 8x plus 3 all over x squared plus minus 5x plus 6, I am going to flip that and change it to multiplication. Then we want to factor and simplify what we can. So let's see. Denominator of the first fraction, I could factor to 4 times the quantity x minus 2. Just seeing what's easy. Okay, numerator of the second fraction. It's also not too bad. And the top left fraction, we have to go ahead and AC that. Right after some thinking, this guy doesn't factor, at least with any of the methods that we know, so we're going to leave it as is. And what else can we do? Those x minus 2's divide out, so really what we are left with. Really what we're left with is 3x minus 2 times 2x minus 1 times x minus 3 all over 4 times 2x squared minus 8x plus 3. So it ends up looking pretty, that happens sometimes. Right here we have 1 over a plus 1 over b over 1 over a squared minus 1 over b squared. And remember way back when we were solving linear equations, we had a bunch of fractions in them. It was advisable to clear them using a common denominator. We can do something like that here, because if I multiply the numerator and denominator, so if I multiply by a squared b squared over a squared b squared, remember, I have to distribute. From the numerator, I can factor out a common factor of AB. And I'll get B plus A. Bottom's difference of two squares. B plus A divides out. So I get as my final answer AB over B minus A. Okay, well, let's see here. Maybe it would be, so I think I want to take a similar approach to this one. Clear the fractions by multiplying by a common denominator. First, I got to figure out what that is, though. So I'm going to factor the top expression. Okay, so it looks like if I multiply by y minus 3 times y plus 4 times y minus 4, y minus 3 times y minus 4 over the same thing. Since the denominator is separated with a subtraction sign, we gotta distribute over that. All right, I promise you it's gonna get better. So upstairs, lots of stuff divides out. The y minus 3, the y minus 4. Downstairs, the y minus 3 and y minus 3. And again, a y minus 4 and a y minus 4. So actually what we end up with is 4 over 3 times y minus 4 minus 2 times y minus 3, which we can simplify. So we get 4 over y minus 6 as our answer, which is much nicer than what we started with. All right, one more. So here we have something. I'm going to show you another option of something that you can do. So what happens if I try to add the two expressions on the bottom together? Well, I need a common denominator, which would be x minus 1. So 1 would get turned into x minus 1 over x minus 1. And I add the numerators together. I have x minus 1 plus 1. So it's really just x over x minus 1. Multiply by the reciprocal. And what I'm left with is x minus 1 over x plus 1. So that's another option for something you can do. You can try to clean up the numerator or the denominator by combining, simplifying, adding, subtracting, whatever. Had we cleared the fractions, we would end up with the same answer. So it's totally okay if you wanted to do it that way as well. Anyway, that about wraps it up for complex rational expressions. Up next, we are going to be solving rational equations, because what chapter of algebra would be complete without solving some equations?